Have you ever really stopped to wonder how an AI actually learns? It turns out it's not just one single thing. At a really deep, fundamental level, there are two totally different philosophies, two different ways a machine can try to make sense of the world from data. So let's break them down.
So here's what we're going to cover. We'll start with the basic problem machines are trying to solve. Then we'll get into a simple way to think about it, the divider versus the storyteller. We're going to look under the hood of those generative models, or storytellers, to see how they tick, figure out how we can trust their guesses, and then wrap up with why this whole distinction is what's behind the AI revolution we're seeing today.
All right, so let's ground this in a really simple idea. Just forget about all the complex AI stuff for a minute and picture this. You have to teach a computer a super basic task.
Yeah, really think about it. Imagine you've got a huge pile of photos. Some are cats, some are dogs. How would you even begin to program a machine to tell them apart? Do you just focus on the differences, like floppy ears versus pointy ears, or do you try to teach it the very essence of what a cat is? Because at the end of the day, that's what a huge chunk of machine learning boils down to. We have our data, right, the images, we'll call that X, and we just want to predict a label Y, in this case, cat or dog. Simple as that. Everything else is about how we figure out that rule. And this is exactly where our two philosophies come into play. I like to think of them as two different kinds of personalities. One is a super pragmatic divider, and the other is this imaginative storyteller.
What's so fascinating is that both of these approaches, they start from the exact same place, a big old set of training data. But right from that starting point, they just diverge. They go down completely different paths. One takes the discriminative path, the other takes the generative one, and they end up in very, very different places.
Okay, so the discriminative approach, that's our divider, is incredibly single-minded. All it cares about is finding the line, the boundary that cleanly separates the cats from the dogs. It's asking, what are the absolute bare minimum differences I need to know to make a decision? But the generative approach, our storyteller, whoa, it's way more ambitious. It's trying to build a full, rich model of what a cat even is and what a dog is. So yeah, the divider is efficient, it's direct, and honestly, for a simple job like sorting cats and dogs, it's often all you need. But the storyteller, because it takes the time to learn the entire story of the data, it gets this incredible superpower. The ability to create brand new examples. Totally new stories that fit that world perfectly. So let's keep going with that. How does this storyteller approach actually work? I mean, how on earth does a machine learn the deep structure of something? Well, it starts by choosing a kind of blueprint. Statisticians have a fancy name for this, a parametric distribution family. But just think of it like deciding you're going to write a specific kind of story, maybe a mystery or a romance, before you've even written a single word. The famous bell curve or a normal distribution is a super common blueprint to start with. You can pretty much boil the whole process down to two main steps. First, you pick your blueprint. You just make an assumption that your data probably follows a certain shape, like a bell curve. And then second, you have to find the exact specific parameters, the details of the story that make the data you've actually seen as likely as possible. It's like finding the one perfect story that fits all the facts you have. Now, this powerful method has a name, maximum likelihood estimation, or MLE. And honestly, the name tells you exactly what it does. Its whole job is to find the model parameters that make your data seem the most likely thing to have happened. So out of all the infinite possible bell curves in the universe, it picks the one single curve where your data points just feel the most at home. Okay, but finding a story is one thing. How do we know if it's a good story? How can we actually be confident in our guess? This gets us to a really critical idea in all of machine learning. How do we even measure if our guess is any good? And this is where the concept of an estimator comes in. An estimator is just the name we give to the function or the process we're using to make that guess. It takes our big pile of training data, crunches all the numbers, and then spits out an estimate for the true underlying parameters of our story. So a good estimator needs to have a couple of key qualities. First, it should be unbiased. Now, this doesn't mean every single guess is perfect. Not at all. It just means that, on average, the guesses are centered right on the true value. It's kind of like a shooter whose shots land all around the bullseye. A biased estimator, on the other hand, is consistently off target. It keeps pulling to one side even on average. And the second property, which is maybe the most important of all, is consistency. A consistent estimator is one that actually gets better the more information you give it. As you feed it more and more and more data, its guesses should start to zero in on the real answer.
Let's actually watch this in action. Okay, with only 10 little data points, look at that, our guess is kind of all over the place. There's a ton of uncertainty here, and a pretty high chance we're going to be way off.
But now let's give it 100 data points. See that? See how the curve gets taller and skinnier? Our guess is getting so much more concentrated right around the true value. The uncertainty just drops like a rock. And finally, at 500 samples, our guess is incredibly precise. There's almost no uncertainty left at all. More data leads to a better guess. That, right there, is the magic of a consistent estimator.
This graph just drives the point home perfectly. As that sample size grows and grows, the probability of being really wrong just plummets down towards zero. And that is exactly what we want from a learning algorithm, right? The more it sees, the more it knows.
So let's zoom back out. That idea we just walked through, that a good guess gets better and better with more data, that is the absolute key to understanding the AI revolution. It's why these models trained on basically the entire internet can become so incredibly powerful. So, keeping that in mind, let's go back to our two personalities, the divider and the storyteller. So here's the final breakdown. Discriminative models are specialists. They are often way better and more efficient at one very specific thing, classification. But generative models, they're generalists. Because they actually learn the underlying model of the data, their abilities go way, way beyond just predicting the label. And those abilities are genuine superpowers. I mean, they can generate completely new text, new images, new music. They can fill in the blanks when information is missing from your data. And they give us this much deeper, richer, more nuanced understanding of how the world is put together. This is the engine that's powering things like ChatGPT and Midjourney. And that leaves us with one final big thought. We started this whole thing by trying to teach a machine to tell the difference between a cat and a dog. But that storyteller path, it led us all the way to a place where the machine can literally dream up a cat that has never existed. So what happens next when that line between learning something and creating something new starts to just blur?